Today let's talk about fixed bias. It's used for biasing BJT transistor. The fixed bias can be shown like this. Okay, according to my experience, a lot of students they get confused about how to apply a KVL. Okay, here we have this the base current, and here we have a collector current. Right. Okay. So this one can be further simplified in this way. We did this because, as we know, any voltage applied to here will be equals to this voltage and will be equals to this voltage. It's like they're in parallel connection, so the voltage must be the same. Right. So from here, some of the students can still getting confused. What can we do here? It's like we can even simplify further. From here, let's see what we can do. You see? Then, as we know, this is at this point we have our base here and we have our emitter here. Okay, we can even simplify further. From here, we can take apart this transistor, this circuit, all of it. How do we do that? How do we do that? We can do it as follows. So how I did it, it's like we have VCC here. And as we can see, this point here is B and here is E. So what is this? Where does it come from? This one, this is 0.7 volts. Where do we get it? Okay, we can get it from, as we know, in this terminal, in base terminal and anode terminal, there is, in base terminal and emitter terminal, there is a diode here, you see. So if you consider this diode to be a silicon diode, so you're going to have a voltage here of 0.7. That's why I put it here. And so we're still going to have RB here, and we are going to have our base current here. So from here, as you can see, it's easy to apply KVL. So how do we do? It's going to be like minus VCC plus IB RB plus 0.7 equals to 0. So I'll be having IB equals to VCC minus 0.7 volts over RB. This is it. We can do the same, the output signals. See? So we'll be having, at the output, we will be having, as we know, this is collector and this is an emitter. So here we have VC and here we have VE. The difference between these two gives us VCE. So if you apply Kirchhoff voltage law at this side, we will be having minus VCC plus IC RC plus VCE equals to 0. Okay, so we're going to have IC equals to VCC minus VCE over RC. That's it. So as you can see here, we have another tip. As you can see here we have VB, a potential at this point A, and here we have VE, a potential at this point, which means that VB minus VE equals to 0.7. So whenever we have VE, we can calculate VB, or vice versa is true. What else can we calculate? As I said, at this point also we have VC minus VE equals to VCE. So if you have one of these, you can calculate another one. Thank you so much.